Boom! In 2024 Jamb examination, or if you have gone through the past question before, you'll be hearing or you'll be seeing some questions on oxidation number. And most of us are already confused. How will I tackle questions on oxidation number? For example, if you are told to solve the oxidation number of sulfur in sulfuric acid, most of you are already confused. How do you know the method, or how can you get the method of solving for sulfur in a compound like this? Or let's say K2CrO2O7. This is potassium heptazodichromic 6. Most of us are confused. How can I solve for chromium in this compound? So in this very concept, I'm going to teach you how you're able to go through this, how you will be able to tackle any question from oxidation number in Jamb 2024. Don't forget, my name is Comrade Gideon, popularly known as Gido Academy. If you have not subscribed to my YouTube channel, do well to subscribe and remain blessed. So let's start. What is oxidation number? Oxidation number is the hypothetical charge of an atom. Is the charge of an atom. Most cases, we don't even know the oxidation number of a particular element. So I'm going to give you a trick, a simple method in which you can get the oxidation number of all the elements in the periodic table. But for the sake of Jamb, let me bring it down to the first 20 elements in the periodic table. So let's go. We have group 1, we have group 2, group 3, yes, group 4, 5, 6, 7, and group 0. We have a hydrogen here. Here will be helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. For the first 20 elements, all elements in group 1, the oxidation number is +1. Element in group 2, the oxidation number is +2. Group 3 +3. Group 4 +4. Group 5 to group 7. What you have to do is this: 5 minus their group number. Sorry, their group number minus 8. Their group number minus 8. So in group 5 will now be 5 minus 8. In group 6, 6 minus 8. In group 7, 7 minus 8. That's to say, all group 5 elements, the oxidation number is -3. Group 6 elements, the oxidation number is -2. Group 7 element, the oxidation number is -1. We already know. My guys said they are unreactive, they are not reactive. But to an extent, we realize that they are still reactive. But for now, let's go with this concept. They are not reactive, they are noble gases, they are noble. They don't just react. So the oxidation number is 0. Remember, 1, 2, 3, 4, -3, -2, -1, and for noble gases, the oxidation number is 0. So let's get started. If you are told to solve for the oxidation number, because Jamb will tell you to solve for the oxidation number of all the elements, he won't do that. Jamb will only tell you to solve for a particular element in the periodic table or in a compound. Let's say, what is the oxidation number of sulfur in this compound? The first thing you have to do is H2, hydrogen gas, plus sulfur plus oxygen is equals to 0. You can write 2 hydrogen plus sulfur plus 4 oxygen is equals to 0. They are the same thing. So let's continue with this. What is the oxidation number of hydrogen in this compound? I would have loved to go deeper, but let's follow this procedure. The oxidation number of hydrogen in this compound, if you come back to this, hydrogen belongs to group 1. And in this compound, the oxidation number of hydrogen is +1. But in hydride, the oxidation number of hydrogen is -1. I repeat. For a compound like this, the oxidation number of hydrogen is +1, which is the one we have here. But in hydride, for example, sodium hydride, this is a hydride, calcium hydride, this is a hydride, the oxidation number of hydrogen is -1. So please, if you are writing, I want you to note that before your exam. Hydrogen here is +1 times 2, close the bracket, plus sulfur, we don't know for sulfur, plus oxygen. Oxygen, we believe that oxygen is in group 6, so 6 minus 8, it gave us 2. That's -2, so we have -2 times 4 equals 0. Plus 4 times 2, we are going to have 2 plus sulfur plus -8 equals 0. That's -2 times 4. So we just write S is equals to Yes, let's make S the solution to formula. If minus 8 crosses the equality sign, it's going to change to plus 8. And if plus 2 crosses the equality sign, it's going to change to minus 2. So the oscillation number of this is plus 6. As easy as that. So if you look at this, if you are told to solve for the oscillation number of sulfur in this compound, the answer will be what? Plus 6. That's why we call it hydrogen tetraoxosulfate 6. Remember, if you check my previous video, I did a video 3 years ago. If you check, you are going to notice that 1, we consider 1 as mono, 2 is di, 3 is tri. So whenever you see 4, your mind should go to what? Tetra. 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 nona, 10 deca, 11 hundred, dodec, that's for 12, tridec is for 13, till you get to whatever you are looking for. So if you look at this compound, let's say K2CR2O7. This question came out in Jamb 2023. What is the oxidation number of chromium in this compound? What you are expected to do is very, very easy. You have to write 2, okay, let me take it like this, plus Cr2 plus O7 is equals to 0. Like what I said the other time, you can as well write 2K plus 2Cr plus 7 oxygen equals 0. I don't want this to look like a 70. That's why I love writing it this format. So with this, let's continue. Potassium is in group 1. So the oxidation number of potassium will be what? Yeah, you are correct. That's plus 1 times 2 plus 2Cr, because you are looking for the oxidation number of chromium, plus, remember, oxygen is minus 2 times 7 equals 0. So you write 1 times 2, that will give us 2, plus 2Cr minus, okay, let me say plus first, minus 2 times 7, that will give us minus 14 equals 0. If you are confused, please play back this again. So I'll write 2 plus 2Cr. If you open this bracket, we are going to have minus 14 equals 0. So if you collect like term, you have 2Cr. Sorry, let's rearrange. Don't make it Cr the subject of formula. 2 chromium is equals, when minus 14 crosses the equality sign, you change to plus 14. When plus 2 crosses the equality sign, you change to what? Minus 2. So we have 2Cr equals plus 12. We are not looking for 2 molecules of chromium. We are not looking for 2Cr. We are looking for Cr. So we divide both sides by 2. Then Cr is equals to plus 6. So if we want to name this compound, it will be potassium. Hepta is for 7. Remember, hepta is for 7. Also, di is for 2. Chromate, and the oxidation number is 6. So if you want to pronounce this, if you want to know the higher part nomenclature of this compound, it will be potassium heptaozodichromate 6. As easy as that. Most cases, they won't ask you to look for the oxidation number and the higher part nomenclature. They will just tell you, you'll be asked, what is the oxidation number of chromium in this compound? And it is very, very easy from what you have done so far. For hydrogen tetrasulfate 6, the answer is 6. While for this compound, the answer is what? Is 6. Now, let me give you one more. Let's play with this. If you have calcium, yes, carbonate, calcium carbonate. Now, if you look at calcium here, okay, let me write calcium plus carbon plus oxygen is equals to 0. We are looking for the oxidation number of calcium in this very compound. So since you are looking for the oxidation number of calcium in this very compound, what you have to do is very, very easy. Calcium plus carbon plus oxygen equals 0. What is the oxidation number of calcium? Calcium is found in group 2, and the oxidation number will be what? Plus 2, as easy as that. Plus carbon is unknown because that's what we are looking for. Oxygen you know already as minus 2 times 3 equals 0. So we have plus 2 plus carbon minus 6. Yeah, remember. Okay, let's say plus equals 0. So we have 2 plus carbon minus 6 equals 0. If you collect like term, you are going to have carbon equals plus 6 minus 2. Carbon is equals plus 4. So if you want to name this, it will be calcium 3 is called tri, oxygen also carbonate 4. So this is limestone, call this limestone calcium triisocarbonate 4, and that's the answer. Most cases we don't really need to do all this. What you need to do, because of time, we don't have time to start calculating all this one in your Jamb exam, because at most 1 minute to a question, at most, if you are very slow in your Jamb exam, that is to say you have to spend 1 minute in one question. That means you might not be able to finish. So I want to advise you, you are not really, it's not a must you do all this long calculation. You need to be very smart in your calculation. So let me give you a method that you can use. For example, if you have magnesium, okay, let me use CO3. This is dolomite. Then remember, if you are very good with radicals, CO3, okay, magnesium here, we already know that is +2. And oxygen here, oxygen is already -2. -2 times 3, what you have to write here, just write -2 here, times this 3. It is also the same thing, just that it's more faster. -2 times 3 here, this will give us -6, and here will give us what? +2. It's very easy. So the answer you are going to have here will be -4. Oxidation number cannot be minus, so change it to plus. So the oxidation number of this compound is as well what? +4. Let me give you another one again. If you have a magnesium tetraoxosulfate 6, you already know the answer as 6. So now let's calculate. Magnesium here is +2. Oxygen here, we are looking for sulfur. Oxygen here is -2. Then -2 times 4, we are going to have what? -8. We have +2 here. And if you let's compute, we are going to have -6. Remember, oxidation number of a particular compound can never be negative. So we write what? Plus. So this is how you can actually solve this instead of following the step 1, the step 2, step 3, step 4, down to the last one. So just for you to think of a better method or a quicker method, then you substitute your values, you get your answer. Thanks for watching. I believe you are able to grab on to for your Jamb exam. Stay blessed and don't forget to subscribe to my YouTube channel. I remain your humble tutor, Gideon Academy. Thank you.